Large signal analysis. Let us study the large signal behavior of the circuit. To this end, we replace the ideal tail current source by a MOSFET as shown in figure A. If V-in1 is much more active than V-in2, M1 is off and so are M3 and M4. Since no current can flow from VDD, both M2 and M5 operate in deep triode region, carrying zero current. Thus, Vout equal to 0. As V-in1 approaches V-in2, M1 turns on, drawing part of ID5 from M3 and turning M4 on. The output voltage then depends on the difference between ID4 and ID2. For small difference between V-in1 and V-in2, both M2 and M4 are saturated, providing a high gain. Figure B, as V-in1 becomes more positive than V-in2, ID1 mod ID3 and mod ID4 increase and ID2 decreases, eventually driving M4 into the triode region. If V-in1 minus V-in2 is sufficiently large, M2 turns off, M4 operates in deep triode region with zero current, and Vout is equal to VDD. Note that if V-in1 greater than Vf plus Vth, then M1 enters the triode region. The choice of the input common mode voltage of the circuit is also important for M2 to be saturated. The output voltage cannot be less than V in Cm minus Vth. Thus, to allow maximum output swings, the input Cm level must be as low as possible with the minimum given by output swings. The input Cm level must be as low as possible with the minimum given by VGS1 2 plus VDS5 min. The direct relationship between the input Cm level and the output swing in this circuit is a critical drawback. What is the output voltage of the circuit when V-in1 is equal to V-in2 with perfect symmetry? Vout equal to Vf is equal to VDD minus mod VGS3. This can be proved by contraction as well. Suppose for example that Vout less than Vf, then due to the channel length modulation, M1 must carry a greater current and M2 and M4 a greater current than M3. In other words, the total current through M1 is greater than half of ISS, but it means the total current through M3 also exceeds ISS by 2, violating the assumption that M4 carries more current than M3. In reality, however, asymmetries in the circuit may result in a large deviation in Vout, possibly driving M2 or M4 into the triode region. For example, if the threshold voltage of M2 is slightly smaller, if V-in1 is greater than one threshold voltage with respect to ground, M5 may draw a small current from M1, rising Vout slightly. Here you can see the figure. A differential pair with active current mirror and realistic current source. B. Large signal input-output characteristic than that of M1. The former carries a greater current than the latter, even with V-in1 is equal to V-in2, causing Vout to drop significantly. For this reason, the circuit is rarely used in an open loop configuration to amplify small signals. Thank you.